Hello everybody, today we're going to cover chapter 7.3, the converse of Pythagoras Theorem. Another word for converse is like the reverse of Pythagoras Theorem. Okay, so far we have learned that for a right angle triangle, c square is equal to a square plus b square. But however, the converse works like this. If I may just present to you an example that I have here. If I gave you a triangle ABC, alright, as shown down here, and I didn't tell you that this angle was 90 degrees. So how can you prove to me that this is actually 90 degrees? Okay, we can use our existing knowledge. So first and foremost, what I'll say is this. I'll look at AB, okay, and I'll say that the value of AB square is 13 square. It gives me 169. Similarly, if I look at AC square plus BC square, that gives me 12 square plus 5 square is equals to 169 as well. Hence, this is the reverse or the converse of Pythagoras theorem in the sense that now with these numerical values, I've shown that AB square is 169. AC square plus BC square is also 169 as shown here. So my statement will be, since AB square is equal to AC square plus BC square, therefore by the converse of Pythagoras theorem, now I can conclude that this angle over here, the angle ACB, is actually 90 degrees, because we know for Pythagoras theorem, C square is equals to A square plus B square. Okay, now I'm just going to show you try it 7 from page 14 to show you how to actually apply the converse of Pythagoras theorem. So now, first and foremost, we have 3 triangles. So let's locate the longer side first, because it's always the hypotenuse, which is c square. So for 7a, the longer side is 5.2 square. So let me write down k square equals to 5.2 square, which gives me 27.04. Now we test it out with g square plus h square is equals to 4.5 square plus 2.8 square, and that gives me 28.09. So you notice that these two values, are they the same? Obviously not. So therefore I can say, since k square is not equals to g square plus h square, triangle GHK is not a right angled triangle. Okay, so in this case, right, I cannot use the converse of Pythagoras theorem, since k square is not equals to g square plus h square. Okay, let me just shrink this down. Okay, now we have part B, triangle XYZ. So again, once again, we look for the longer side. The longer side will be 65 cm. So I'll say that y square is equals to 65 cm square is 4225. Then I will take the other two sides, 33 and 56. So I say that x square plus z square is 33 square plus 56 square. And lo and behold, the value is also equals to 4225. Then I'll say, since y square is equals to x square plus z square, so by converse of Pythagoras theorem, okay, you need to write this statement. By converse of Pythagoras theorem, okay, triangle XYZ is a right angled triangle. Then we move on to page 16. It's try it 8. So in try it 8, right, what you would need to find is the length of PR. So in this case, what we need to do here is this. Before you actually attempt to try to find PR, you may be very tempted to go and think that this is a right angle triangle. It sure looks like one. Okay, but in this case, I think before we can do any of that, what we actually need to do is to be able to prove that this is actually a right angle triangle. So first and foremost, I will start by saying this. I will say that PS square is equals to square root of 74 square is exactly equals to 74. Then PQ square plus SQ square is equals to 5 square plus 7 square, and it's also equals to 74. So so I'll say this: since PS square is equals to PQ square plus SQ square by the converse of Pythagoras theorem, angle PQS is equals to 90 degrees. So what I've done here is to prove that this angle, what I've done here is to prove that this angle here is 90 degrees. So we can't assume, right? So that we have proven this, let me just shrink this. Now, the next thing here is this. So now I can find the length of PR since it's a 90-degree triangle. Sorry, a right angle triangle. So I say by Pythagoras theorem, PR square is equals to 5 square plus 3 square. PR is equals to the square root of 34, and PR is equals to 5.83 cm. Okay, for part B is something that is quite interesting actually. So what's the shortest distance of Q to PS? So just imagine, let's just imagine that this triangle is a field. So you are at point Q now and you want to walk to PS. What's the easiest way or the fastest, shortest route to get to PS? Would you walk this way? Now that is a rather long way to get to the line PS. How else can you walk? Maybe you can walk this way. Yep, that is shorter than what we took in the first route. But of course, you all will know that the easiest way is to walk in the straight line across the field like this at a 98-degree angle. And that will give you the shortest distance from Q to PS. So let me label this shortest distance here. Let me call it X. So now what I can do here is this. One thing about a triangle is no matter how you look at it, the area doesn't change. So now for example, if I use this, I say PQ is a base, whereas my height will be QS. So my area is half times base times height, which is I think 17.5 cm square. So that is the area of the triangle. If you rotate the triangle and PS is the base and X here is the shortest distance, so it will also be half times base times height over here. So we know that since the area of the triangle can't change, so I will say this, I will say that half times square root of 74 times X is equals to half times base, which is 5 times 7. So I can eliminate the I can eliminate the half straight away. So what I will get here is X is equals to square root 74 times X is equals to 35. So if I divide both sides by square root of 74, my X value is 4.07 cm. That gives me the shortest distance from Q to PS. Now I'm going on to question 4 of exercise 7.3. So if you can just pause the video, turn to page 16 of your textbook. Now for this, find the lengths of PQ and RQ. So first and foremost, I'll just very quickly do this. I may not want to talk so much about this. So I will say for part A, I'll find PQ first by Pythagoras theorem. For you one, I'm just going to save these words at the side there. So later I can save writing it once. So I will say that PQ square is equals to 9 square plus 12 square. PQ is equals to square root of 225. The value of PQ is 15 cm. Similarly, if I apply by Pythagoras' theorem, that's where it comes in handy. So by Pythagoras' theorem, similarly, I will say that QR square, sorry, they want me to find RQ, not QR. So I say RQ square is equals to 12 square plus 16 square. RQ is equals to square root of 400. So the value of RQ is equals to 20 cm. So let me just label what we've just found. This was 15. This was 20. Then this entire length here is 25. Now let us just erase this. Okay, so what we'll do here is this. We want to find out if PQR is a right angle triangle. So what I'll do here in part B is I will say that we find the hypotenuse, which is 25, okay, or the longer side. PR square is equals to 25 square, which gives me 625. PQ square plus QR square is equals to 15 square plus 20 square. It gives me the same value of 625. You notice the working, it just repeats itself. So do note down how to present this answer, because it's very common for us to ask a question such as this. So now what I'll say is this. Since PR square is equals to PQ square plus QR square by converse of Pythagoras' theorem, okay, triangle PQR is a right angled triangle. And now we have come to the end of the last question of 7.3 before I give you your homework. Okay, now what we have here is this question 6. It can be found on page 16. Okay, I will just quickly, I will skip certain parts of the question because I think it's a repetition. So for a rectangle, you know that all these angles will be equals to 90 degrees. Okay, so now what I can do here is this. They want us to find BP. Okay, so they want me to find BP. So BP, you want to find BP, you consider this triangle. You consider 5 and 12. You apply Pythagoras' theorem. This will be 13 cm. Similarly, for QP itself, okay, for PQ rather, for PQ, we'll consider this right angle triangle. This 18, this 7.5. Later on, I will show you the working. This will give me 19.5 cm. Similarly, if I apply Pythagoras' theorem, I can also find the length of BQ there. So I'll just show you the working. If you really want to see the working here, I will just pause the video for a short moment and take down the working for how I found BP, PQ, and BQ. That's quite a mouthful. Alright, okay, now let us just move on to the next part of question. So the question is, determine if BPQ is a right angle triangle. So that's the focus of this topic. That's why I keep going through this over and over again. So same thing here. First, I will say that AB, okay, so AB is equals to 23 cm. Okay, AQ, okay, what's the value of my AQ? Sorry, I am a bit confused here. Okay, never mind. So for part B, determine if BPQ, so let me just dive into the answer itself. BP square plus PQ square is equals to 169 plus 380.25, which we found earlier. So this answer here gives me 549.25. Okay, similarly, BQ square from earlier is also equals to 549.25. All these values were gotten from here. So I will write my statement since BQ square is equals to BP square plus PQ square. So by converse of, you can say it out together with me, Pythagoras Theorem. Triangle BPQ is a right angled triangle. Okay, now the last part is this. Try to find the shortest distance from P to BQ. So if you can just take a moment now, okay, before the video carries on, to actually draw, okay, we found out this is 90, to draw where this shortest distance is. So the shortest distance is from B to PQ. You draw the perpendicular. So this distance x is the shortest distance from P to BQ. So similarly to the example we have done earlier in the lesson, the area of the triangle doesn't change. So first I will say this, half times BP times PQ. Okay, so it's half times base times height. So what I'm doing is I'm taking this as the base, I'm taking this as the height, okay, for this triangle here. Then it's equals to half times base, which is BQ, times the height x here. So let me just write that down as half times BQ times x. Okay, so we just fill in the different values here. So the different values that we get is half times 13 times 19.5 equals to half times BQ, which is 23.4 times x. If we solve, we will get the x value to be 10.8 cm. And that concludes the presentation for